And new title of section 1 is the angular displacement. First, let's remember what displacement from the 11th grade, which is the linear displacement or the translational motion. So remember, in the displacement of the object is defined in terms of the reference point or reference frame. For example, position of this car can be determined according to a point, which can be a it can be a bus stop, it can be a statue or something like this. And if the object is car moves from one point to another point, final position, so then you draw a line from initial position to the final position. It is called the displacement, linear displacement of this car. But first you should determine a reference frame to define this position and the displacement of an object. In circular motion, it is also very similar to this one. So you are going to define the motion according to a reference line, not reference point. For example, here is the an object which is at initial position according to this reference line. And later this object is starting to move from this point to another point, like this one. It's the final position. And of course, its position is changing both in terms of the distance along the circle and also angle with respect to the reference line. So then this object is initially at a point which is on the reference line, but then it's travel a distance. It travels a distance from initial position to a final distance position on the arc. Remember, in math, this is called an arc. So it's moving on an arc, and it attains another position by the time it's turning by an angle of theta, delta theta, because there's a change. So after a time of interval delta t, the object moves to a new position. When it's doing this, the distance delta is traveled by the object along a circular path. So the object follows a distance along this curved path. This is called arc length. Remember, in maths, we said this before, but now we are going to say delta s because there's a change by time. By the time this bicycle is turning some angles, so the angle delta t through which the object turns is called angular displacement. So delta s is the arc length. This object displaces or moves on an arc whose length is delta s. By the time this bicycle is turning by an angle of delta theta on a circle whose radius is r. So remember, we are able to relate as theta and r, and we will do it again now in this section. But first, let's define what angular displacement is. The angle through which an object is rotated in a specific direction is called angular displacement. So then, equation again relates theta s and r the same. Delta s is equal to delta theta is equal to delta s over r. Delta s is the arc length in meter, radius is in meter, delta theta is in radian. So rotating in a specific direction, because we say that, which means this direction can change. So if the rotation is, if the revolution or motion is clockwise, both delta s and delta t is negative, clockwise rotation or clockwise revolution. So delta s or delta theta will take in negative. Clockwise means in the direction of the clock. Clock is rotating like this, or that's why it's the rotation is called as the clockwise, and it's negative. If the rotation is counterclockwise, it's going to be taken as positive. And one revolution and one rotation corresponds to an angular displacement is 2 pi or 6.28 radian. Like what? One rotation of minute hand, second hand, and hour hand of a clock, like this. Second hand, minute hand, and hour hand. So they rotate. One rotation, for example, from 9 to 9 of the clock of the hour hand, or from 11 to 11 for the minute hand, from 12 to 12 for second hand all have the same angular displacement, which is 2 pi radian, 6.28 radian. One rotation of Earth, Moon or Sun around their own axis. One revolution of the Earth around the Sun. One revolution of the Moon around the Earth. One revolution of a car on a circular track. All they have the same angular displacement, which is 2 pi radian or 6.28 radian. And let's do some exercises. Shazat rides on a carousel that is rotating clockwise. When it says clockwise, negative. He travels through an arc length of 11.5. Arc length, delta S. Delta S is equal to negative 11.5 meters. If the child's angular displacement is 165, delta theta, again negative, so both of them is negative, negative 165 degrees. What is the radius of the carousel? Calculate R. So we will get R by the equation, which is equal to delta theta delta S over R. But we never use degree in calculation. Always we should convert this degree to radian before starting making a calculation. Then delta theta in radian, I should get it, which is equal to pi over 180 degrees multiplied by delta theta in degree. First, I should convert it. Let's calculate delta theta in radian is how much? Pi is 3.14 divided by 180 multiplied by angle is negative 165 degrees. Now let's do the calculation. 3.14 divided by 180, yes, multiplied by negative 165 close bracket, so 165 bracket closed, which is equal to negative 2.88 radian, if you round it, 88 radian. Now we converted degree to radian. Now we are ready for using equation. Delta theta is equal to delta S over R. But questions about R, we know what delta theta is, what delta is, just cross product. So then R times delta theta is equal to delta S. Then R is going to be calculated. That's why I simplify delta theta by dividing both sides by delta theta of the equation. So then R is equal to delta S over delta theta, or simply exchange their position. Delta S is negative 11.5, delta theta negative 2.88. So now let's calculate negative 11.5 divided by negative 2.88, close the bracket, which is equal to 3.99, which is almost 4 meters. Radius of this carousel is 4 meters. And a beetle sits at the top of a bicycle wheel of the flies away just before it's squashed. If the wheel turns clockwise, again negative clockwise, beetle's angular displacement is pi radian. Delta theta, because it's clockwise, delta theta is negative pi radian. Corresponding arc length of 1.2 meter, delta S is equal to negative 1.2 meter. Again, calculate the wheel radius R. Again, same made this way. So delta theta is equal to delta S over R. We will calculate I. Just cross product and exchange their position. That's why R is equal to delta S over delta theta. Delta S is negative 1.2 divided by delta angular displacement is negative 3.14. Let's use it. Calculator. Negative 1.2 divided by bracket negative 3.4, which is equal to negative 0.35, negative 0.35 meters is the radius of this wheel. And there's other practice problems, same method you are going to use here. That's why I'm going to skip this one. You can do it on your own, it's not so hard. 17. And these are some problems, also not so hard. I'm going to skip them again. We will continue with angular speed. Okay, so then in what linear motion or translational motion, you first define what delta x is, remember, in the 11th grade. After defining delta x, which is the linear displacement, then you define the speed, v, remember, speed. Now we did the same thing. First we define what delta theta is, which is the angular displacement, so it's now time to define speed. But the speed is not about the linear motion, it's about the angular motion, rotational motion. That's why it's called angular speed. Angular speed. Angular speed is defining how fast an object is moving on a circle, or an object is spinning or rotating, how fast. So, as I said, linear speed describes how quick an object or point moves. It describes distance traveled in a specific time interval. Remember, you define as delta s, delta x over delta t. In the object moves, if an object moves a distance of delta s from here to there in a time interval delta t, you can calculate the linear speed by delta s over delta t or delta x over delta t. But the same thing can be done according to angle. At the same time, object rotates an angle of delta theta in a time interval delta t. So it's moving and also rotating, moving in a circular direction. So a speed related to rotational motion can also be defined, which is known as angular speed, average angular speed, omega average. So what is the definition of angular speed? First, average angular speed is the rate at which a body rotates about an axis. When it says rate, you will understand that physical quantity is divided by time over delta t. So what is changing here as object is rotating? Of course, angle is changing. That's why there's a change in angle, delta theta. Rate of change, this rate of change in angle, which is average angular speed. And it also describes how quickly the rotation occurs, how quickly, how fast it is rotating or moving or on a circle. It's also defined as rate of rotation, the rate of rotation. So it's calculated by the ratio of the angular displacement delta theta to the time interval delta t, which is average angular speed. And the unit of average angular speed is radian per second because angular displacement is radian, time is second, radian per second is the SI unit of average angular speed. And let's solve a problem. Raskar spins on a stool in counterclockwise direction, positive, with the average angular speed of 4 radian per second. So omega average is 4 radian per second because it is counterclockwise. In what time interval? Delta t. Question. Will the Raskar speed have an angular displacement of 8 pi radian? Delta theta is the angular displacement, which is positive 8 pi radian. So calculate delta t in what time interval? We know that average angular speed is equal to delta theta divided by delta t. Delta t is the question. Cross product, change, delta t is equal to delta theta divided by omega average. Delta theta is 8 pi divided by omega average, which is 4. So 8 over 4 is 2, which is 2 pi radian per, 2 pi second. Sometimes you need to leave the answers by pi, especially the last 2 years they are doing this so frequently, but sometimes you need to convert it, you need to multiply it by pi, 2 times 3.14, which is equal to, now I need to write it, 6.28, of course, 6.28 second. Okay, this is the time interval. And A car tire rotates with an average angular speed of 29 radian per second. Omega average is 29 radian per second. In what time interval? Again, delta t. Will the tire rotate 3.5 times? What does 3.5 times mean? Remember, I defined this when I was explaining rotational quantities. It's defining about the revolution, of course. So on a circle. So from here to the 1 time, 2 times, 3 times, and a half, 3.5. So that's for revolution. Times means revolution. Revolution. Or rotation. Rotations. Okay, so then angular displacement here is given as, because it's talking about the rotation. 3.5 rotations. So it's not a SI unit, we should convert it to radian. In what time interval? Delta t is the question. Okay, first let's convert. Delta theta in radian is equal to every 3.5 rotation. We know that every rotation is 6.28 radian. So every rotation is 6.28 radian. So then if you multiply 6.28 by 3.5, so let's get first 3.5 multiplied by 6.28, which is equal to almost 22 radian. So it's equal to 22 radians. Now we can calculate what delta t is. Omega average is equal to delta theta over delta t. Because delta t is the question, cross product, delta t is equal to delta theta over omega average. Delta theta is 22, omega average is 29, 22 over 29, 0.76, 0.76 almost, 0.76 a second. You can do this practice too. I'm going to skip it. Get familiar with the clock. Yes, these clock problems are very important. A clock has 3 arms or 3 hands. Hour hand, which is shortest. Longer one is minute hand, and then longest length, which is the second hand. But their time of rotations are different. Second hand of the clock completes one rotation in 60 seconds. It starts from 12. It takes 60 seconds, don't forget. When the question is about the second hand, it's one rotation takes 60 seconds. But minute hand of the clock completes one rotation in 60 minutes. So that it takes longer. So 60 minutes, one rotation of the minute hand. 60 minutes, how many seconds? If each minute is 60 seconds, 60 times 60, which is 360 seconds. So minute hand completes one rotation in 360 seconds. But hour hand is the slowest. It completes one rotation in 12 hours. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 12. 12 hours. 12 hours. Every hour is 60 minutes. So every minute is 60 seconds. 12 times 60 times 60 seconds. It takes one rotation of hour hand. For example, there's a question. How long, delta t, how long means delta t? Does it take the second hand? Questions about second hand. Remember, one rotation is 60 seconds, remember. Of a clock move through 4 radian. 4 radian, how long? Okay, do we know that one rotation takes 60 seconds? Yes, second hand is this. One rotation takes 60 seconds. One rotation, how many radians? Of course we know it. One rotation, one revolution, 6.28 radians. Take 60 seconds. But the question is what? 4 radian. 4 radian takes how many seconds? Just simple cross product. Let's do it. 6.28 times x is equal to 4 times 60. 4 times 60. Divide by 6.28 divided by 6.28. X is equal to, let's calculate. 4 times 60 divided by 6.28, which is equal to 38.2 seconds it takes. 38.2 seconds. And section of questions about the angular speed. A cyclist rides along a circular track. If cyclist travels around exactly half the track, this is important. Exactly half. Half the track means semicircle. Half the track. Because it's a circular track, but half of that track is traveled. Semicircle is traveled. And track is going to be like this. It's a circle, but not all. Half of it. From here to there, cyclist travels. Yeah, this is the track. In 10 seconds, half the circle, which is the, that delta theta for a semicircle is pi radian. Pi radian, which is equal to 3.14 radian. Delta t, which is equal to 10 seconds. It takes 10 seconds. What is average angular speed? Omega average is what? We know that omega average is equal to delta theta over delta t. So then omega average delta theta for half the track, which is semicircle, is pi radian, which is 3.14. Time interval is 10, which is equal to 0.314 radian per second. And one more question. Find the average angular speed of Earth about the Sun in radian per second. Hint, Earth orbits the Sun every 365.25 days. Okay, this is the Sun. Earth is moving on a circular path around the Sun. Huh? So Earth. So it takes one revolution, delta t, means days 365.25 days. What is the angular displacement for one revolution? Everybody knows. One revolution, whatever that object is, not important. One revolution, always 2 pi radian. So delta theta, 2 pi radian, which is 6.28 radian. Delta t is this, 365.25 days. Calculate average angular speed. Use the equation for average angular speed, which is equal to delta theta over delta t. Delta theta for every object which makes one revolution. Earth, Sun, Moon, whatever, one revolution. 6.28 radian divided by time. But this time is in day. It must be converted to second. Like what? 365.25 days. Every day, how many hours? 24. Every hour, how many minutes? 60 minutes. Every minute, how many seconds? 60 seconds. When you multiply them all, you will get the answer. Let's do it now. 365.25 days. Every day is 24 hours. Every hour, 60 minutes. Every minute, 60 seconds. Multiply them all. Don't forget. 6.28 divided by, but don't forget to put the bracket. Otherwise you will get the answer incorrect. 365.25 multiplied by 24 multiplied by 60 multiplied by 60, which is equal to 1.99 times 10 to the power of negative 7. 1.99 times 10 to the power of negative 7 radian per second is the answer.